अब स्टूडेंट्स कुछ बात करेंगे about the data rate limits. What it essentially means is how much data in bits per second can be sent over a particular network, over a particular link, or over a particular channel. Students, data rate or how much data can be sent over a channel depends on three factors. The first one is what is the bandwidth available. The second one is what is the level of the signals that we are going to be using. And the third one is what is the quality of the channel, as in what is the noise level of the channel. Students, there are two different theoretical formulas. There are two different theoretical models that were presented to calculate this theoretical data limit. The first one was presented by a scientist called Nyquist, and this is used to calculate the theoretical maximum data rate for a noiseless channel. Noiseless channel where noise is equal to 0, something that is not possible in real life. The second formula or the model that was given was by a scientist called Shannon, and that is what we use to find out the theoretical possible data limit or data rates for a noisy channel. Students, आप देखेंगे आगे जाके in the discussion that in reality, for practical reasons, we use both of these for every single signal to actually find out the theoretical limits of where we can operate. Let's move on to a figure and let's discuss the first one, which is the Nyquist formula in further detail. Students, the first theoretical formula or the theoretical model that we have was developed by Nyquist. It is called as Nyquist bitrate or Nyquist rate formula. And as I told you, the Nyquist rate formula is used to calculate the theoretical maximum bitrate for a noiseless channel, a channel with noise equal to 0. Students, how we calculate the bitrate in this case is our bitrate is equal to 2 multiplied by the bandwidth multiplied by log to the base 2 L. Students, in this case, the bandwidth is equal to the bandwidth of the channel. In this particular case, L is the number of signal levels. This is the number of signal levels that we are going to be using to represent the data, and then our bit rate is, of course, our bit rate in bits per second. Now, students, when you look at a point that I want to make before I move on to the next slide, with this formula, what you can see is that our bit rate looks like as if it is directly proportional to the number of levels. Students, what this means is if we can keep on increasing the number of levels, we can essentially have an infinite bit rate, isn't it? Now, students, theoretically, this looks correct from this Nyquist rate formula. However, in real life, we need to find a balance between bit rate and system reliability. And what I mean by that is that if you keep on increasing the levels, the two levels that we normally use, say 0 and 1, they are easily accommodated. They are easily handled by a data communication system. But if, for example, you have got multiple levels, say you have got 20 levels, then your sender and the receiver, they need to be able to distinguish between those 20 different levels. If you have got two levels, you have got a 0 and a 1. Both the sender and the receiver are only playing with these two levels. Now, if you go to 20 different levels, you will need to have a sophisticated sender and a sophisticated receiver, especially the receiver, for it to be able to distinguish between 20 different levels. So, by increasing the levels, yes, you are increasing the bit rate, but at the same time, you are compromising your system reliability. So we need to find a fine balance between the number of levels that we are going to be using to represent the data and the system reliability. अब स्टूडेंट्स कुछ एग्जांपल्स करेंगे. In the first one, we have got a noiseless channel. Bandwidth is 3000 hertz, and it has got two signal levels. We need to find the maximum bit rate. Very quickly, we have just done a similar problem in the previous slide. So 2 multiplied by 3000 hertz, which is our bandwidth, multiplied by log to the base 2 of 2, and this gives us a maximum theoretical bit rate of 6000 bits per second. Students, our next example, and in this one, we have got once again a noiseless channel, 4 signal levels. For each level, we are sending 2 bits, and we need to find out the maximum theoretical bit rate. Once again, we have 2 multiplied by 3000 multiplied by log to the base 2, but instead of 2 this time, we have got 4 levels. Students, our bit rate goes to 12,000 bits per second. पिछली स्लाइड पे वापस लेके जाऊंगा आपको. इस केस में we only had 2 signal levels, so we calculated the log to the base 2 of 2. Our resulting theoretical maximum bit rate was 6000 bps. Next example once again. In this case, our number of levels are 4. We have doubled our bit rate. Bit rate is directly proportional to the number of levels that you are going to be using, except that you need to take care of the system reliability. You need to find a fine balance between the actual bit rate that you want to achieve versus the number of levels that you're going to be using.